today we are looking at ratios. Now, a ratio is just the relationship between two numbers or quantities, and we can describe that relationship as part to part to whole, or whole to part. So what do I mean by that? Well, if we're looking at this example, we've got some squares, triangles, and circles here. Now, if we wanted to describe the relationship of squares to circles, for example, we can see that there are 5 squares and 3 circles. So the relationship of squares to circles is 5 to 3. Now you notice, since I said squares to circles, the number representing squares is first and circles is second. And this is how we can write a ratio. We can also represent it with words, so we could say 5 to 3. And we can also represent it as a fraction, 5 to 3. Okay, so that would be a part-to-part ratio. Another example would be if we wanted to compare the ratio of circles to triangles. We have 3 circles and 2 triangles, so that would be 3 to 2. Okay, now we could also compare them as part to whole. So if I wanted to look at the ratio of triangles to all of the shapes here, there are 2 triangles, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of the shapes in total. So we could say that that is a 2 to 10 ratio. And just like with fractions, we could actually simplify this if we wanted. And so we could say there's a ratio of 1 to 5, meaning for every 5 shapes here in total, there's 1 that is a triangle. Now, we could also do whole to part, which would just be changing that order there. So for example, the ratio of shapes to circles, we have 10 shapes and 3 circles. So that's how we write our ratios. Now, we can write the value of the ratio as a fraction. So the value of the ratio A to B is A over B, right? So like in that example where we were looking at the circles to the total number of shapes, we said it was 1 to 5. So the value of that ratio is just written as 1/5. All right, so we're going to take a quick look at equivalent ratios. Now, equivalent ratios would just be like this example we had up here, 2 to 10 and 1 to 5. We can see that those are equivalent ratios, just like we could see that they are equivalent fractions. So as long as you multiply your numerator and denominator by the same number, you're going to have an equivalent fraction. So for example, we can see that 1 to 3 and 2 to 6 are equivalent because 1/3 times 2, we get 2/6. So let's practice a couple of these here. Are they equivalent? 4/3 and 20/15. If you want to pause here and do this work, determine for yourself if they are equivalent, go ahead and do that. So if we're looking at this, we can go ahead and write out our ratios as fractions here. We have 4/3 and 20/15. Now, is there a number that I can multiply 4 and 3 by to get 20 and 15? Well, I know that 4 times 5 equals 20, and 3 times 5 equals 15. So yes, these are equivalent ratios. What about 5/7 and 10/21? Sorry, not 5/7, 5 to 7 and 10 to 21. Okay, again, we could write them as fractions, 5 to 7, 10 to 21. Now, with this one, we can see that they are not equivalent because we know that 5 times 2 equals 10 and 7 times 3 equals 21. So these are not equivalent ratios.